Okay, this is for my chemistry students. This is sig figs and how to do your homework. I found another document that I uploaded to Edmodo. It looks like this. It's sig figs. So it gives you different ways to look at sig figs and how to determine whether a zero is significant. So using the first method, they divide zeros into three different categories. The ones that are leading zeros, the ones that are captive zeros, and then the ones that are trailing zeros. So let's take a look at a few numbers and see if we can categorize them. Sorry, let me take a look at this because I just leading. Trailing, that was the word I was looking for. So let's look at what a leading zero is. We said that any number that is non-zero is significant. So here are some non-zero numbers. And everyone would agree that that has 4 significant digits. But what if I put zeros in front of it? How many of those are significant? According to the rule we just read, if there are zeros in front or to the left of your non-zero numbers, then these are not significant. And they're what we call placeholder zeros. In other words, they're only there for the purpose of showing you what the value of the number is. So that this is 2 times 10 to the minus 1, 2, 3, 4, 5, rather than 2,000. So they just show you where its value lies. Those are leading zeros. And now we have trailing zeros. Let's take 2173 again, and then put zeros behind it. Trailing zeros without a decimal are also not significant. Notice, however, that they do give this number a particular value. So now we've got 21 million instead of 2,173. So these zeros give it value. They show you that it's much greater than 2,000. Up here, these zeros give it value. They show you that this number is much less than 2,000. So if they are leading zeros, like these here, leading zeros, or trailing zeros, they are there as placeholders only, and they're not part of the measurement. They are not significant. Then the last category that they had was what they had called captive zeros. In other words, it's in the middle of a number surrounded on either side by non-zero digits. So an example of that would be 10005. These are all significant because they have a significant digit there and a significant digit there. So let's count significant digits in each one of these numbers. If we look at the first one here, we are not going to count any of those zeros. They are not significant. So this number has 1, 2, 3, 4 significant figures, so it has 4 sig figs. In the second number here, we are not going to count any of the trailing zeros. So this also has 1, 2, 3, 4 sig figs. But when we look at this number here, because all of the zeros are significant, this has 1, 2, 3, 4, 5 sig figs. It has 5 significant figures, or 5 sig figs. So those are the general rules. Now, if we come back and look at this sheet again, they have what they call an Atlantic Pacific rule. So let's look at the Atlantic Pacific. It's all about the decimal when you're looking at these numbers. So if you look here, you'll see that the decimal point is what's critical. With the trailing zeros, they're at the right end of the non-zero digit, but they are significant only if the number contains a decimal point. So here is an example. The number 100 with a decimal point. That decimal point makes every single one of those zeros significant. So 100 decimal means this last zero was actually measured, and this number has 3 sig figs. Without the decimal, the number has 1 sig fig. So it is this magic little decimal right here that indicates whether the zeros are significant or not. So let's take a look at what we call the Atlantic Pacific rule. If zeros are present, let's see if I can get kind of funky with this. I never know with this smartboard. If a decimal point is present, whoo, it's working. Okay, cool. The decimal point is present. We're going to begin counting on the Pacific side. Now, let's see what that means. We're going to pretend that this blob is North America, because I'm not even going to try to draw it. Let's get rid of this line. Okay. The blob is the North American continent. We will call it NA for short. Okay. On the right-hand side is the Atlantic Ocean. And on the left-hand side is the Pacific Ocean. So the left-hand side of your decimal is Pacific, and the right-hand side of your decimal is the Atlantic. And we'll let the decimal be the continent. Sure. Okay, whatever. So on the Pacific side, the first non-zero, counting all of the digits until you reach the other end of the number or measurement. So that's the decimal point. So here is the thing. Let's say you've got this number, 215.000. We're going to start counting. There's the decimal. Decimal is present. That's it right there. So that's our continent. Oops. Okay. So we're going to start on the Pacific side right here and counting with the first non-zero digit. 2 is the first non-zero digit. So this has 1, 2, 3, 4, 5, 6 sig figs. So you count from the first non-zero digit all the way to the end. Let's say you have a different, I have no idea why that thing is doing that. Okay, so let's say you have a different number. Let's say I've got 0.0005261. Following the same rule, begin counting on the Pacific side. So there's your continent. This is the Pacific side, but it's a 0. So you begin counting with the first non-zero number. So that means I'm not going to count that one, I'm not going to count that one, or that one, or that one. I'm going to start counting with 5. 1, 2, 3, 4. This number has 4 sig figs. If the decimal point, oh, well, let's throw in one more thing, because I can hear you out there saying, well, what if there's a 0 at the end of that one? So let's throw that in there. Let's make this 52610. Again, none of the leading zeros are significant. Start counting with the number 5. 1, 2, 3, 4, 5. This number with a 0 at this end adds an extra significant digit, so this number has 5 sig figs. Why? Because this incredibly small number, the way it's written, indicates that this 0, albeit uncertain, was actually measurable. In other words, your instrument was sensitive enough to be able to pick up that number. So that's what you have to remember, that we're not talking about random numbers here. These are all measurements as far as we are concerned. They're all measurements. Okay, so let's erase all of this stuff. Yeah, the board's fun, isn't it? Okay, erasing all of that stuff, let's look at if the decimal point is absent. So absent here, let's go back to the highlighter. Absent goes with Atlantic. Got it? So you can keep those two similar. So if the point is absent, begin counting on the Atlantic side with the first non-zero, counting all of the digits until you reach the other end of the measurement. So here's the example. 3, 4, 5, 0, 0. There is no decimal in this number. So I'm going to start on the Atlantic side, which is going to be over here. So this is the Atlantic side. I'm going to start with the first non-zero number. So I'm not going to count that one, and I'm not going to count that one, and I'm going to start with this one. 1, 2, 3. This number has 3 sig figs. So let's do another one. Let's do, well, that's the example. But, let's say that I have this number here, 800 decimal. So this has a decimal, which means it no longer falls under the Atlantic rule. Now it falls under the Pacific rule because it is, decimal is present, P present, P Pacific. So you start on the left side with the first non-zero digit. You count all the way to the end. So the first non-zero digit on the Pacific side, and I'll just put PA on this side to help you remember that's Pacific. 8 is the first non-zero digit. 1, 2, 3. So this number has 3 sig figs. So why don't we work the first few problems of your homework, shall we? I think that would be lovely. Yes, let's do that. Okay, let's get rid of this quickly. And I'll go to your homework page. Counting sig figs. Let's start with question number 40. The number is 0.0086. So there are 2 different rules that you can use. Each one should give you the exact same answer. If you say the Atlantic Pacific, again, the Pacific rule says you start on the left-hand side because there is a decimal. And you count starting with the very first non-zero digit, which happens to be 8. 1, 2. This has 2 sig figs. Conversely, if you want to use the leading zero rule, you'll see that each one of these zeros is also considered to be a leading zero. So they don't count. So it doesn't matter which rule you use, you still come up with the same answer. So 0.0086 has 2 sig figs. Let's look at problem number 26. 0.00620. Again, the Atlantic Pacific rule, this is going to be the Pacific rule because it has a decimal. So you start on the left-hand side and you count, starting with the first non-zero digit. That doesn't count, that doesn't count, that doesn't count. 1, 2, 3. This has 3 sig figs. Let me work one more for you. Let's look at problem number 20. Now, this is missing a comma or has too many zeros, depending on how you want to look at it. 0, 0, 0, 0, 0, 0. I'm going to pause for just a second and let you see if you can come up with the correct answer. Seconds up. Okay. Either way you want to look at it, you can consider these zeros trailing zeros, in which case none of them are significant, or you could look at the Atlantic Pacific rule. Again, there is no decimal, so it's the Atlantic. So you start in the Atlantic side, and you start counting with the first non-zero digit. So those don't count. 1. And the answer for this is 1 sig fig. Okay? Excellent. So now let's take a look at the rounding rules. So, whoopsie, let's erase all of this. Having fun with the board. Okay, try this again. Okay, this is going to be a little snarky. Okay, I know you all are laughing at me right now because I can't use the smart board. Yay! Okay, Next one, rounding off. Basically, it's exactly the same way as in math, but because these are measurements, we do not always want to round up. Because if we always round up, we will make our answers always too high. So half the time we round up, the other half of the time we round down. So if you end up with a number that ends in the number 5, this only is interested in 5. 5 is the magic number. Okay, so if the digit to the immediate right of the last sig fig is equal to 5 and is not followed by anything other than a 0, then we're going to use the even-odd rule. The even-odd rule is this. If the number right next to the 5 is even, we round it down. So 7.45 becomes 7.4. This is the digit we're trying to round, the 4. Do we round it up or do we round it down? If, on the other hand, the digit right next to the 5 that you're trying to round is odd, then we round it up. So 7.35 is rounded to 7.4. Notice it's always going to end in an even number. So half the time we're rounding up, the other half of the time we're rounding down. And the even-odd rules are intended to reduce the accumulation of errors in chains of calculations. Okay? Note that you should always end up with an even number with these rounding rules. Now, that only refers to the number immediately adjacent to a 5. Let's see if this comes up with... Okay, now, having said all of that, that's where it stops. Okay, so here are some examples, and let's come over to this one. If I have this number 63.5, and I want to round this digit here, so I want to round it so that it has 2 sig figs. Sig fig, round it to 2 sig figs. That means I've got to round to 63.5 to 60 something. The question is it going to be 63 or is it going to be 64? So in math, you would always make it 64, but this is applied math, so we've got to make it the rounding rules. So because the 3 is an odd number, we're going to round this to 64. Here's another example. I like being colorful. 724.5. And I want to round this number so that it is 3 sig figs. That's what I want to round it to, 3 sig figs. So that means 1, 2, 3. This is the digit I'm trying to round right there. Does the 4 go up to 5 or does it stay as a 4? Because of the even-odd system, since the 4 is immediately adjacent to a 5 followed by nothing, I'm going to round it down. This becomes 724 with 3 sig figs. Now, let's take this number and change it just slightly. Let's make it 724.51. Now, what am I going to do with it? I still want to round this number to only 3 sig figs, but it's not next to a 5 all by itself. Now the 5 is followed by a 1. So I still leave it at 724, or now do I round it up to 725? And so the easiest way for me to try to explain this to you is with a number line. So we'll put 400 here, and we'll put 500 here on a number line. Exactly in the middle would be 450, but I have 450 1. So because it's not exactly in the middle and it is closer to the 500, this will round up because it's closer to 500. So 724.5, and I want to round this digit right here because I'm rounding to 3 sig figs, becomes 725 because it's closer to 725 than it is to 724. Okay? So basically, you're going to round this one up just like you would in math. The only time you have the even-odd rule take effect is when it ends awkwardly with just 5, and you've got to round the digit immediately next to it. So here's another example. Let's say that I've got this number here. 815, let's make that 8151.2. Okay? And I want to round that so that it has 1 sig fig. I want to round it to 1 sig fig. So if I only want to round it to 1 sig fig, this is 1, 2, 3, 4, 5 sig figs. That means I want to round the 8. And so the question is, do I round the 8 up or do I leave it exactly the same? You're going to use the same rule here as you do with math. The thing that determines whether or not you round the 8 up is the number it is adjacent to. It is adjacent to a 1. In math, you would leave it alone. But I cannot round it to 8. Why can I not round it to 8? What was the number I started off with? 8,151.2. Now, if I made those dollars, hopefully, it would make a lot more sense to you. I have about $8,000, or I've got $8,151.2. I'm going to round it to the nearest thousand. Here you go, let me give you $8. I think you would complain. To round it to the nearest thousand, I would give you 8,000, not 8. So, taking away these decimal places actually changes the value. So you have to replace it with the placeholder zeros so that it becomes, or retains its value. So this number, 8151.2, rounded to 1 sig fig, would round to 8,000 and not 8. So let's work a couple of your problems from the homework. Let's look at number 8. Speaking of 8, we have lots of 8s on the mind here. Problem number 8 is 0.0155, and you're supposed to round it to 2 sig figs. So the first thing you have to do is determine how many sig figs are in this number. That's the first most important thing. So we're going to go back to let's use the Atlantic Pacific rule. It's easy to explain, it's easy to use. I got a decimal, so the decimal is present. I'm going to start with a Pacific side, and I'm going to count significant digits. That's not significant. That is not significant. This is digit 1, that's digit 2, that's digit 3. I want to round it to 2 significant digits, which means I've got to round this 5. Do I round it up or do I leave it the same? It's next to a 5 followed by nothing. So to round that number, I'm going to round it to 0.0. Remember, the value has to remain the same. 0.016, because 5 is odd, and our even-odd rounding rules dictate that we round it up. So that rounds to 0.016. Let's work one more. Let's do number 4. The number is 1.034, and I want to round that to 2 sig figs. Once again, I must determine how many sig figs are in this number. This 0 right here is what we call the captured 0. But let's use our Atlantic Pacific rule again. The decimal point is present, so we're going to start with the Pacific side and count our significant figures. 1, 2, 3, 4. This number has 4 sig figs. I want to round it to 2 sig figs, which means I've got to round that digit right there. I have to round the 0. So is the 0 going to go up, or is the 0 going to stay the same? It's next to a 3, which means it's going to stay the same. Rounded, this number becomes 1.0. Okay? So hopefully this helps you. If you have any questions, maybe you can ask your parent. Maybe the parent's picked up on this by now. So you need to have, in your measuring homework, you need to have all of section 1 done, which is counting the sig figs and also in rounding. So you need to have those 2 done by the beginning of the period tomorrow. Remember, homework is graded for completion, and if you do not have your homework at the beginning of the period, it becomes the ugly goose egg. So please be sure that you have it with you at the beginning of the period. Good luck with your homework, and I'll see you tomorrow. Bye-bye.